Alrighty, pre-algebra class, it is time for us to turn to section 3-4, using formulas. It can be found on page 145. Using formulas is a very interesting section because we're going to use math we've already learned. So we're not really learning any new math. We're just going to learn how to use some old math in a new way. All right, let's go ahead and get started. First, we do have a definition that we do need to copy down. So, a formula is an equation that shows a relationship between quantities that are represented by variables. Okay, if you don't understand that, once we look at some examples, hopefully you'll understand it. But before we look at some examples, let's really try to break this definition down so we can understand it a little better before we see examples. A formula is an equation, which means it's going to have an equal sign that shows a relationship between quantities. Quantities mean like an amount, so numbers. And these numbers, or amounts, are represented by variables, meaning we're going to have letters. So we know it's going to have an equal sign. We know it's going to have some variables in it, letters. We know that all of this is supposed to help us understand the relationship of how these different amounts affect each other in a way, in the relationship. Let's look at some examples of some formulas. Here, as an example, is the distance formula. You have D is equal to RT. This is a formula that shows the relationship between the distance traveled, the rate, or the speed at which you're traveling, multiplied by the time. So, for instance, if you're going on a trip and you wanted to know how far you've gone, look at your speed, look at how long you've been traveling, and that will tell you the distance you've traveled. Okay? I think you'll understand as we work some of these examples out more. Another formula that y'all should be familiar with is this, the perimeter formula. It's where the perimeter of a rectangle, this is for a rectangle or for a square, but a square is a rectangle, so kind of redundant to say that. So the perimeter is equal to 2L, meaning the length, plus 2 times W, and W is the width. So the perimeter is equal to 2 times the length plus 2 times the width, okay? And here's another example of a formula, Celsius to Fahrenheit formula. There's a formula you can use to convert Celsius degrees in temperature to Fahrenheit degrees of temperature. So Fahrenheit is equal to 1.8 times Celsius, the temperature. That's what that C stands for, the temperature in Celsius, plus 32, okay? So let's look at how we would use some of these formulas. So, for example 1, we're told to use the distance formula to find D, R, or T. So what's going to happen is they're going to give us 2 of the variables and we have to find the missing variable. All right, so let us take a look. Let's just work this one out. Okay, so right here we have R is equal to 50 and T is equal to 3. So copy down the distance formula like I'm going to do right here. Put D is equal to R T. Now, underneath that, replace the variables with what numbers they give you. It doesn't give me anything for D, so I put D back as itself. The R is replaced with 50. What does it mean when 2 variables touch? To multiply. You could have used parentheses if you wanted to, or you could just put a times symbol between them. Either way is fine. And you have 3. So what does D equal? Well, D is equal to 150. Because that is what 3 times 50 is. It's 150. Okay? Simple enough. We're given this formula. It gives us 2 of the letters. We plug it in. We find the one that we don't know. And now we know what it is. Now, this was a pretty straightforward one. Let's look at a one that has a little extra step to it. What about this one right here? This one over here gives us D and it gives us T. So what are we looking for? If we know T and we know D, the one we don't know is R. So we're going to plug it in. I'm just going to go ahead and plug in from the get-go. So my D is equal to this. So I have 350 is equal to R times 5. Okay? I want to know what R is equal to. We've got a problem. Unlike the other one, where the variable was already by itself on one side and all the numbers were on the other, here the variable is on this side with a number. If only we knew a way to get rid of a number when it's on one side of an equal sign in an equation. I wonder if there's a way to get the variable by itself. Oh, wait. We could just divide both sides by 5 because division cancels out multiplication. This would leave us with R, and so we would get R is equal to, what does R equal? Well, what is 350 divided by 5? It would be 70. So our rate, the R you could also say as maybe speed. The speed we're traveling is 70. And we could say 70 miles per hour. We're not really told in this. You'll be given, like, it might tell you miles or kilometers traveled, and this would probably tell you 5 hours. So you'll have all that. So when you write down your answers, you need to include those, whatever units it might be including. For us, we're going to stick with just the simple miles and hours and miles per hour. Okay? Let's look at some more examples. Here we have a rectangle, okay? And we're going to use this rectangle, the numbers we have here, the length and the width, to find the perimeter of this. So if you're given the perimeter formula, like above, you have P is equal to 2L plus 2W. Replace with what you have. I don't know the perimeter, but I do know the width and I do know the length. So put P back by itself is equal to 2 times 13 plus 2 times 5. Now, you could have used parentheses again. You could have put this inside parentheses and that inside parentheses, and it would also tell you to multiply. But you don't have to. Okay? So here we have our P is equal to, well, that would be P is equal to 2 times 13, which is 26 plus 10. P is equal to, and it's equal to 36. Now, we don't just stop there because up here it does give us measurements. We're measuring in meters. The perimeter is going to be equal to 36 meters. Okay? All right. Well, let's move on to the next problem. One where we have change to Fahrenheit. It's 50 degrees Celsius. Is that warm or cold? Well, 50 degrees in Fahrenheit is pretty cold, but what about Celsius? How hot is that? Let's find out, shall we? Using the formula that we were given, we will say that Fahrenheit is equal to 1.8 times 50 plus 32. Now, you might need to go to the side and do some scratch work to figure out what this is, but 50 times 1.8, that is going to be, so we say Fahrenheit is equal to, well, this right here equals 90 plus 32. So we add that together, and the temperature is Fahrenheit, in Fahrenheit, would be 122 degrees. Ouch! I don't know. Does it get that hot even in like Mexico or, the equator? I don't know. Maybe Africa on a really sunny day? But that would be extremely hot. So 50 degrees Celsius is extremely hot. So be mindful of that. All right, so that's how you use formulas. Now, in class, you do need to be prepared that we are going to have a variety of formulas. It's not just limited to these three. These are just three examples that we will see in class, but there's many more. So the idea is this. You'll be given a formula. You'll be told what some of the letters are equal to, and then you have to find the missing letter or letters. So plug in and solve, just like you would an equation. Sometimes it'll be straightforward. Sometimes it might take a few steps. All right, write down any questions you might have and be prepared to answer my questions in class. See you then.